Good evening and welcome to a special Astronaut presentation to celebrate International Asteroid Day. My name is Irene Porro and I am a director of the Mccauliffe Center at Framingham State University. I am delighted to host tonight's guest speaker, Dr. Alisa Daji, and I want to welcome you all who chose to join us tonight. We have a very rich program prepared for you, so we want to get going right away. First, though, a couple of housekeeping notes. Please be aware that we are not using the chat function on Zoom today. If you would like to ask any questions, and we do hope you do, please post them in the Q&A window on Zoom. You can locate the Q&A button on the bottom right of a Zoom window. To get started now, I'd like to first introduce Mary Mcdonald, Planetarium Programs Manager at the Mcauliffe Center. Mary hosts the Mcauliffe Center Astronaut series every other Friday, and I encourage you all to check our website to find out about our upcoming astronaut events. Here it is. This evening, Mary will offer a brief introduction to the solar system and asteroids, and will then introduce our guest speaker. So let's get started. And Mary, our virtual stage is all yours.
Thank you very much, Irene, and welcome again, everyone, to our special Asteroid Day presentation. My name is Mary Mcdonald, and I am the Planetarium Program Manager with the Mcauliffe Center. I do encourage you to check out our website. We do have some upcoming events in the month of July, virtual events at this time, and we'll be adding more all the time. So what we're going to be doing really quick today is just talking a little bit about the background. What is an asteroid? You know, we're all here to talk about asteroids. And we're going to start by taking a look at the solar system. So this is a view of the solar system. And humans have been searching for asteroids and interested in asteroids for a very long time, even before the word asteroid existed. And in fact, even before the concept of the solar system existed, people were aware of the planets, Mercury, Venus, or not, well, they were aware of Earth, not quite sure what it was, Mercury, Venus, Mars, Jupiter, and Saturn. And then in the late 1700s, another planet was discovered, Uranus. It was the first planet discovered in thousands of years. And in fact, it was really the first planet discovered at all because the others had just always been known. And after that, it was suddenly everyone was searching for planets. They were looking to try to see if there were more planets in this solar system. And in fact, between 1801 and 1807, 4 planets were discovered. And all of them were in the region between the orbits of Mars and Jupiter. So let's zoom in on that region. And I'll point out one of the planets that was discovered in this region. It was called Ceres. So you see here between the orbits of Mars and Jupiter. And I said planet because yes, when it was discovered, it was declared to be a planet, as were 4 other bodies discovered in the same region. Eventually, more and more were discovered, and it became clear that there was no planet here. There was something else going on. And this is the region we now know as the asteroid belt. So what I am going to show you now is I'm going to show you, let me first turn off the stars so we don't get confused by stars. I'm going to show you the locations of some, but not all, of the known asteroids at the present day. So hopefully you can recognize that this is not totally realistic. The asteroids do not look like this. They are not that close. We're not really that close together. If anyone recognizes the scene behind me, this is from Star Wars. And this is not what the asteroid belt looks like. The asteroids are, there's a lot of them, but space is very big. There's a lot of space between them. So what you're seeing on screen here is a little bit unrealistic because the asteroids are definitely not this color, and they are not this bright. In fact, they're pretty difficult to see in general. They're very small, typically very dark. Originally, the entire solar system looked like the asteroid belt. It was a messy disk filled with small bits of debris, and eventually some of the bits started sticking together and they formed bigger conglomerations, and these became the planets. Now, the largest one happened to form right outside the region now known as the asteroid belt, and that was the planet Jupiter. And it's pretty interesting to really find out about the incredible influence that Jupiter has on the entire solar system. It is the largest planet, and the gravitational influence of Jupiter pushes and pulls on the objects in the asteroid belt constantly. And these gravitational forces made it so that a big planet could never form in this region. The pieces were constantly getting pushed and pulled in all different directions, either sending them flying out or never really able to stabilize. But eventually, many of these small objects settled into stable orbits. They're mostly in orbits that allow them to stay out of Jupiter's way, which is what allows them to continue to orbit. And the majority of them are in this region that we call the main belt, and that's where Ceres is. Ceres is the largest asteroid, by the way. Not surprisingly, it was the one that was first discovered. But not all of them are in the main belt. So if we get a little bit closer, we can see that there are some asteroids that have different types of orbits. So for example, some of them, like this one called Eros, which is a large asteroid, cross the orbit of Mars. And these are called Mars-crossing asteroids. And some of them even cross into the orbit of Earth. So I've got a special one that I want to highlight, the asteroid called Bennu right there. So see how its orbit crosses the orbit of Earth, which is shown in green there. This is I guess sometimes call them Earth crossing asteroids, but there's actually many different groups of Earth crossing asteroids, and not all Earth crossing asteroids are necessarily ones that we consider near Earth objects or anything that is potentially dangerous. So there's a lot of asteroids. There's a lot of different ways to categorize them. And there is also still the influence of Jupiter and each other that causes orbits to change. So these Earth-crossing asteroids, they're not necessarily ever going to collide with Earth. Just because two paths cross doesn't mean the two objects will ever occupy the same place at the same time. But there are definitely some that could. What scientists, though, are really concerned about are not about the asteroids so much that they already know about, but maybe the ones that they don't know about. And more are being discovered all the time. Since the discovery of Ceres in 1801, over 900,000 asteroids have been discovered, and it is estimated that there may be over 1 billion asteroids in this general region. One of the goals of Asteroid Day is to raise awareness of this issue among the public and to highlight the work being done by scientists, engineers, and policymakers to build understanding of these rocky bodies and how they might affect us on Earth. And so I'm just going to quickly say that Asteroid Day was adopted as an international day by the United Nations in 2016 in order to observe each year at the international level on the anniversary of the Tunguska impact over Siberia, Russian Federation on June 30th, 1908, and to raise public awareness about the asteroid impact hazard. So that's the UN resolution to observe Asteroid Day, but the movement actually began before that, back in 2014, by a team that was led by many people in the community, including Dr. Brian May, astrophysicist and lead guitarist of Queen. The first Asteroid Day was organized in 2015, and the UN recognition came shortly afterward. So I am very excited to have with us one of these policymakers and policy analysts that we have just mentioned, who are very, very important to this movement, to this work. Joining us today is Dr. Alyssa Hadaji. Dr. Hadaji is a lecturer in space law, policy, and sociology at Harvard University and leads the United Nations mandated Planetary Defense International Working Group. And I think that she can do a much better job talking about all of these issues, especially in the policy realm. So I'm going to turn it over to Alyssa. You can go ahead and share and introduce yourself. Thank you.
Thank you, Mary. And I first would like to thank Irene and Mary, the Mcauliffe Center, and Framingham State University for having me today on Asteroid Day. So I wish you all a happy Asteroid Day. And I will make the bad pun immediately that I hope your day rocks, because I thought about it all day and I had to say it. And I just need to make a quick edit to my introduction. I lead the ad hoc legal working group of SEMPAGE, which is part of the group of scientists that work on planetary defense, but I do not lead the entire planetary defense group at the UN. I would be yelled at if I were to not correct that. I'm here today because we're going to talk about space law and policy. And what policy means is that we're pretty much going to talk about the strategies that are in place when you have to deal with planetary defense with a potential asteroid or a comet that would impact the Earth. So I'm going to share my presentation right now. Here we go. And we'll get started. Here we go. So planetary defense one-on-one, or who to turn to when an asteroid is about to hit you. And I was almost about to call this talk, Who You're Gonna Call, like Ghostbusters, because let's be honest, we're going to talk about asteroids. You probably heard about it all day because it's Asteroid Day. And when we hear about planetary defense, our first thought is to think, oh, I didn't even think that something could hit the Earth and kill us all. This is terrifying, and I want to hear about it. And what I want to share with you today is to in some way reassure you, because there are tons of wonderful experts all over the world who are working on these issues to detect asteroids, to understand them better, to find technologies to push them away if they were ever to become a threat to the Earth. And you also have policymakers and lawyers and just so many different disciplines and experts who are working on those issues so that you don't have to worry. And I'm very excited that you connected today, because you too, as a citizen of Earth, want to know more about how to protect the Earth. And I'm going to tell you more right now. So first of all, I'm going to explain a few definitions so that we are sure that we're talking about the same things and there's no confusion in your mind. I'll do a very quick history about the field of planetary defense itself. And the reason why you might have never heard of it before is because it's a very young field. If you think about it, and when we'll go through the history of the planetary defense world, yes, we've talked about Tunguska and things that happened 100 years ago, but really the management of those threats is about 20 years old, something like that, 20 to 30 years old maximum. So it's a very young domain, and you had scientists, astrophysicists, researchers who collected data at the very beginning about those potential threats. And now you have this development of a real managerial structure, and which is becoming a real policy structure that I will go through as well. And finally, I will give you some advice on places where you can learn more about the field of planetary defense. So in terms of definitions, and I'm going to be really strict on that one. So I work on planetary protection and I work on planetary defense. And I keep on hearing people invert those names. It is not the same thing. So you have on, I'm not gonna say right or left because I don't know how you're seeing this slide, but on one side you have something called the International Planetary Protection Handbook. And when you hear about planetary protection, it's about how you're gonna decontaminate your spacecraft so that when you send it somewhere and you want to sometime find signs of life, you make sure that you're not bringing things with you, like life from Earth, onto the place where you're trying to find life. So you're trying to avoid false positives, etc. And you want to make sure that when you bring samples back, you might not contaminate the Earth with things that you don't know about. So those are planetary protection guidelines. When you hear about planetary defense, however, we are talking about asteroid and comet that can impact the Earth. That's what planetary defense is about. But if you talk to the communities, both of them, they will tell you that it would actually make sense to call planetary protection planetary defense and planetary defense planetary protection. So the confusion ends here. I just wanted to highlight this because even in news articles and papers, you're going to find sometimes those two names being intertwined. Remember, today we're talking about planetary defense. So what is planetary defense? I wrote down a definition, and I will talk a little bit later about SEMPAGE, exactly what it is, but the short version of what SEMPAGE is, it's Space Mission Planning Advisory Group, and it's a UN-mandated scientific group that comes together to think about those missions that may be needed to potentially push away an asteroid impact threat or a comet impact threat. And what you can remember this by is just to remember, we just all need to be on the same page. It's a bad space pun again, but it's a useful one. So what is planetary defense? It refers to the activities and actions meant to monitor, predict, prevent, prepare for, and respond to a potential impact by an asteroid or a comet on Earth. And I know today is Asteroid Day, so why am I talking about comets? Well, because in the world of planetary defense, we're not just saying if an asteroid were to impact the Earth. We understand that sometimes comets can also impact space objects, and Earth included. So we call them near-Earth objects, those objects that are near the Earth that could impact the Earth. And in that category, we define it as an asteroid or a comet with an orbit that brings it within 1.3 astronomical unit of the sun. So that means that that object is coming approximately 200 million kilometers away or 120 million miles away. And I'm putting those big million numbers in because, again, when we talk about asteroids or comets that could impact the Earth, don't imagine that something is, about to hit us, that it was like 1 kilometer away or 3 kilometers away. Most of the time, we're talking about millions of kilometers away. So it's good that we have political structures and that we have scientists to look at comets and asteroids. And as Mary said, I would love if it were true and if asteroids were big, green, flashy lights in the sky that we could track, but usually they're pretty dark and they're hard to detect. So it's absolutely important to make these kinds of research. But we want to make sure also that we know that we don't need to go into a panic. And when we say that an object is a near-Earth object, we're not talking about something that is so close to the Earth as we could imagine. We're talking still about objects that could come close to millions of kilometers away from us. Another definition that I wanted to mention is natural threat. So right now, if you look at the UN definitions of natural threats, they will tell you that it's a non-man-made incident caused by a biological, geological, seismic, hydraulic, or meteorological conditions that may cause those disruptions on Earth. And right now you don't see, asteroids and comets in it. It's only because right now we have not officially defined an asteroid impact as a natural threat, but it's something that is being worked on and that might enter into the international definition of what a natural threat is. And I just wanted to remind you that I'm making that distinction because there are a lot of different topics in the space world, and natural threat is different than man-made threats. One example of a man-made threat would be space debris. Space debris are growing to become really man-made threats to the Earth and to humans. So some of the notions that I've talked about, the near-Earth objects, as Mary specified, we've found a lot of asteroids already. But near-Earth objects, those are coming close to the Earth, we found 20,000 of them. And out of those 20,000, some are called PHOs, potentially hazardous objects. And sometimes you're going to find the acronym PHAs, which means potentially hazardous asteroids. But again, PHOs is larger. It includes asteroids and comets. And to this day, we found about 2,000 of them that we're currently tracking. Again, that does not mean that those PHOs are threatening the Earth right now. It just means that they're closer than most asteroids and comets that we know of. And we want to make sure that we are prepared if somehow they were to cross the Earth's orbit and could be dangerous for us. Another notion that I wanted to highlight is the difference between a disaster and a catastrophe. And I want you to be reassured because in the next few years, especially in 2029, when you'll hear a lot about the Apophis asteroid, the Apophis is coming close, Apophis is going to create a catastrophe. Yes, Apophis will be called a near-Earth object. As we just explained, it doesn't mean that you need to be worried about it immediately. And when we talk about disasters versus catastrophes, disasters mean that it's going to be relatively local. So if a city, a region, even maybe a small country is destroyed by an asteroid or a comet impact, so I'm going to say a near-Earth object impact, an NEO's impact, that would be a disaster. If we happen to have an object that is larger in size and that could eradicate an entire world region, a continent, or the entire Earth, we would talk about a catastrophe. Finally, the last notion that I wanted to bring to your attention is the word scotomization. And it has nothing to do with science. It actually has to do with psychology. And it's because when we think about the idea of having a large object eradicating everything that we know about in this world and eradicating our world, our brain could go into a certain kind of shock. And this is what scotomization is about. It means that if we warn population and we tell them, you need to move, your country might be destroyed soon, some people will not move, not because they want to defy authority or because they don't care or because for religious reasons they believe that it's the path to the afterlife. No, there are also some who will not be able to absorb the information. Their brain is going to be in such an amount of shock because nothing in the past, in the history of humanity, has prepared humans to learn that kind of information and to absorb that kind of information, that life as some people know it would go extinct immediately. So that the kind of psychological notions from the social sciences that are useful for policymakers to just keep an eye on, because when we would, or if we were to ever have to move away populations, those kind of notions will be important for the people on the ground to share this information properly to the populations so that they can actually take actions. So those sizes, as I said, I made this distinction between a disaster and a catastrophe. Usually when we talk about near-Earth objects, we distinguish those who are going to be smaller than 140 meters. Those one could have national effects. We have those who could be bigger than 300 meters, and those one would have large regional effects. And then you have objects that are more than 1 kilometer in diameter, 1 kilometer wide, and those would have global effects. For example, I think you've heard potentially of Chelyabinsk, the asteroid that, technically the meteor, because it did not impact the Earth. So meteor, an object that comes in and in some ways disintegrate into the atmosphere, this one exploded, and meteorite means that it actually reached the Earth. This meteor that exploded over Chelyabinsk in the 2015, 2014. I have my slide with the history of it right after. But that object was about 20 meter, something like that. It was about a 6-story high building. So you can imagine that this was not supposed to have national effects. It was not supposed to have even more than local effects. And luckily it did not impact the ground, but the shockwave broke some glass. And that's also why those kind of small objects, even though they're not registered as being important because they're not gonna have national effects. They can harm people and they need to be tracked as well. But those smaller objects are some of the most difficult ones to track. So what can we do if an asteroid or comet were to impact the Earth? We have some mitigation methods. That means ways to push away, destroy, do something about it. And I'm not going to go over this long list. I just wanted to go over the first two. One is to explain to you what a kinetic impactor is. And the short version of this is if an object were to come towards you, it's a way to punch it and push it away. That's what an impactor is. It's going to impact the object. So I'm going to read the definition. It's a high velocity impact of a spacecraft. So you're literally throwing a spacecraft at the nearest object. So it's a high velocity impact of a spacecraft into a nearest object, and it transfers momentum to it, thereby changing the orbit of the nearest object. So it doesn't really destroy it, it pushes it away. And the ejected material from the impact can enhance the orbit change and pushing it further away. Another method is using a nuclear device. And note here, please, that I'm not saying a nuclear weapon, I'm talking about a nuclear device. And we'll maybe talk about this in the Q&A potentially, but also further along in my presentation. A nuclear explosion close to a nearest object and or below its surface, what it would do, it means that this explosion, this nuclear device explosion, would create a radiation that would vaporize the surface material and eject it at a high speed. So you have the object, have something that explodes, then radiation, and it ejects the material from the rock that is then pushed away. So the pressure wave from that explosion on or above, below the surface can also cause large pieces of the nearest object to fly off. And that's kind of one of the risks. If you break apart an object, you want to make sure that you're not creating more object that could fall a little bit everywhere. With sufficient energy, the nearest object can be completely split into small pieces. However, some of those pieces can recombine. And also you can have large pieces that are going to be split and then could fall on you. You have other methods that are possible. You have the laser ablation, you have the gravity tractor. I'm sure we'll be able to make those slides available to you, but if you go onto websites like the Planetary Defense Coordination Office of NASA, you'll be able to learn a little bit more about the technology side of mitigation methods. But today we're going to talk about the history of planetary defense and really dig into what does it mean and what are you supposed to do if an asteroid were to come to hit you. So one of the first things that happened was in 1994, and it's called the Comet Schumacher-Levy 9. One of the scientists who found it was called Schumacher. The other scientist who were to find it was called Levy. That's how it got the name Comet Schumacher-Levy 9. And why it is important, it's because it's the first time astronomers were able to see directly the impact of a comet on a large object in the solar system, meaning here Jupiter. So Jupiter was impacted by this comet in 1994. And I don't know if you've seen pictures of Jupiter ever, but it has this really red cyclone-y dot on it that you can see from very far. Well, that impact was more visible than this red dot. So it's kind of what started this whole conversation of, oh, if we're impacted this way, this could be really bad for Earth and for all of us. So in 1999, at the international level, the United Nations has an office, the Office of Outer Space Affairs, and they organize big committees and big reunions of people. And one of them, called Unispace 3, happened in 1999. And this is when, for the first time at the international level, policymakers and lawyers and scientists came together and said, we should talk about planetary defense. We should talk about just getting more data about those nearest objects, because what happened to Jupiter could happen to Earth. In 2003, in Japan, a mission Hayabusa was launched to an asteroid. And for the very first time, we got a sample back from an asteroid. It was the very first time we were able to get a sample back from an asteroid. In 2004, a larger object, Apophis, which I talked about a little bit earlier because it's coming back in 2029, not impacting the Earth, but it's coming back. Apophis came close to the Earth in 2004, which enabled scientists to get a lot of data from it. In 2013, see, I said 14, it was 13. In 2013, you had the event above Chelyabinsk. And in 2014, you had the creation of I-1 and SEMPAGE. So remember earlier when I said that SEMPAGE it stands for Space Mission Planning Advisory Group, and it's the way we can all be on the same page about planetary defense. Well, I-1 is the Interagency Warning Network. I think that's, no, and maybe I'm wrong on that acronym, too many acronyms in the space world. I-1 is this group of observatories of researchers all around the world that collect data on asteroids and comets and near-Earth objects. And it tracks and understands those objects to make sure that we can follow them. And if one becomes threatening, it would warn SEMPAGE. So SEMPAGE it's a group of scientists, international scientists mandated by the United Nations who are in charge of creating a mission if something were to become threatening. I-1 is that another group of scientists, international scientists from all over the world, who are tracking and observing and keeping track of those objects and would contact SEMPAGE for if anything were to be threatening. I have a little graph a little bit later to show you that connection between the two. And actually, we had planetary defense conferences happening since 2004, but starting in 2015, they developed an idea that was a planetary defense scenario, meaning that those scientists, the I-1 scientists, the SEMPAGE scientists, all the scientists who work on planetary defense in general, would come together at this conference, and instead of just sharing their data and their research, they would also role play a potential asteroid impact threat over something like a week. So at the end of every day, they would have the scenario and they would have to make decisions, and they would role play decision makers, UN decision makers often. And this is, you can see in 2015, that's only 5 years ago. This is when we started to train at an international level every 2 years to prepare for those potential scenarios that SEMPAGE might have to apply one day. And then at a national level, following up this evolution, you had the NASA Planetary Defense Coordination Office. So the first office dedicated to planetary defense within a space agency. And that was created in 2017. And not too far later, ESA, the European Space Agency, got its own planetary defense office in 2019. So what is this planetary defense management? Because in 1994, you had the Schumacher-Levy-Nye comet that impacted Jupiter. Then you had some groups that started to get together. But what are those structures? Who are you supposed to call if something happens? So first of all, I want to show you this graph that is often shared when we talk about near-Earth object, and here near-Earth asteroid specifically. And I want to make sure that you see that it shows an increase in NEO detection, not an increase in near-Earth objects, period. You know, if you look at this graph and you don't look at the title, you're going to think, oh my goodness, we did not know, but there's a multiplication of near-Earth objects and we're all going to die and they're going to impact us. Look, there are almost 20,000 of them. This is catastrophic. My English, I apologize for that one. But that's not true. Actually, the reason why this number was so low prior to the 2000s is simply because they were not looking for them. We didn't have that type of technology. And with the increase of awareness and the increase of technology and the increase of policies, then we were able to have more people working on the domain, and naturally, we discovered more objects. So what did these institutions started? How did they start? So we talked about it at the UN level. This big coordination committee group that comes together is called UN COPIUS, United Nations Committee on the Peaceful Uses of Outer Space. And sometimes they have a name when they come up every year. So you have a technical committee, a legal committee, and one with diplomats and everybody. And this one in 1999 was called Unispace 3. Then at the UN level again, you have this Action Team 14, that was their name. And it sounds kind of Power Ranger-ish. But in 2001, they got to work and thought about this kind of structures that would be needed if we were to control and understand better planetary defense and create some strategies. And it's this action team 14 that came up with the idea of I1 and SEMPAGE that were founded in 2014. Then, out of this international framework, you had national policies that started to be established. One of the main one being the US National Near-Earth Object Preparedness Strategy and Action Plan that was proposed in 2016 and then confirmed in 2018. And the NASA Planetary Defense Coordination Office that I talked about earlier in 2017, and the one in Europe in 2019. So at the international level, oh, here you are. Here I can finally get my I1 acronym correctly. So it's not interagency, that's for debris. It's the Interagency Space Debris Mitigation Group, I apologize. Here, I1 actually stands for International Asteroid Warning Network. That's what they're called. So at the UN level, as I said, you have this United Nations Committee on the Peaceful Uses of Outer Space, and they mandated those two groups, the International Asteroid Warning Network. So this group of international scientists who look up and try to find and characterize those objects. And then you can see on this little drawing that if the object has more of a 1% chance of impacting the Earth, and if it is larger than 50 meter wide, because again, if it's larger than 50 meter wide means that it could have national effects. So it needs to be a little bit big so before we make big decisions, right? Otherwise it could disintegrate into the atmosphere or have very small local impacts. So at the international level, you have the I1. I1 is observing everything. And if they detect an object that is more than 50 meter wide and has more than a 1% chance, to impact the Earth, then SEMPAGE is activated. But in reality, SEMPAGE is currently working because they are planning in case one day they were to have to make those kind of decisions. So what does SEMPAGE does? It was created, as we said, in 2014. And the objective of SEMPAGE is to prepare an international mitigation mission in case of a confirmed asteroid impact threat to the Earth. Currently, there are 18 members to SEMPAGE. I think it's even a couple more since last year. And this group of international space scientists created an ad hoc working group of lawyers to answer their legal questions. And that's the group that I ended up having the chance to coordinate. This group brought together 15 international lawyers. And you would ask, why would those scientists need lawyers in play and just why? Well, those lawyers were asked two main questions pretty much. One was this question of liability for damage, meaning if you're a big country and you can push away an asteroid, and we learn, let's say I'm the United States, and we learn that there's this big object that's gonna fall on Belgium. Sorry, Belgium. Well, if I help push away this asteroid, but something goes wrong, and instead of falling on Belgium and just being pushed away and gone forever, potentially I push it away, but not far enough, and it falls on Russia. Would the United States be liable for damage if that happens? So that was one of those questions, because if those kind of legal problems happen, then you would have maybe large countries who could do something about a planetary defense problem and would not, because they wouldn't want to be liable and leave certain countries in difficulties. And we don't want that. We want collaboration and coordination among all countries. Another big issue is the question of nuclear devices, because when you look from the previous slides on the ways to push away an asteroid, nuclear devices, the use of a nuclear device was pretty much high up on that list. However, using a nuclear device in space is very problematic in terms of international law. I will not go too much into this, but if you're interested, I will be more than happy to refer you to the report that we've submitted in April that explains exactly why and how it would be difficult based on international law to use a nuclear device, and also what kind of new roads we could explore to potentially make this possible if needed. So just to give you an example, because NASA has its own planetary defense coordination office, I wanted to also show you the ways some of those offices are structured. So you have the NASA administrator. associate administrator, the Planetary Science Division, and within the Planetary Science Division, then you will have a group that looks at near-Earth objects and observations, and under this one, you'll have the scientists who are participating in I-1. So again, I-1 is not part of NASA, it's an international group, but the American scientists working within that branch will also be connected and will be I-1 members. Same thing if you look at the complete right, you have the mitigation research project team and those who will be in charge of pushing away the asteroid. Well, under this lies people who are American scientists who are part of SunPage and who are also part of NASA to make sure that those groups are well connected and the information circulates. And finally, this is, I think, it's the funniest slide that I have. So I hope you'll like it. It kind of shows you the way a decision is being made if an asteroid were to impact. So let's say you start with the yellow dot. An object is detected with an initial orbit determination that is being made. And they ask you, is it very close approach to Earth? Yes, it has a very close approach to Earth. Is the potentiality of impact higher than 1%? Yes. So in your head, you're already thinking, okay, that means that SunPage will be informed and will do something about it, and you would be correct. But right now we're within NASA. So let's see what NASA is planning. So if it's a very close approach and has a potentiality of impact of more than 1%, then there is a notification process that is initiated. Oh my goodness, there is a potential impact, really? Well, if there is no potential impact and it's visible, if the object is visible between the Earth and Moon and visible from the Earth, then NASA would warn the public. If it has a potential, that's if it doesn't have a potential impact, but the object is still visible. So it's fun to kind of consider the fact that if it doesn't have a potential impact and it's not visible, the NASA would potentially not warn the public. Haha. If it has a potential impact and it's confirmed, then the Planetary Defense Coordination Office would warn the NASA administrator. The NASA administrator would warn the Executive Office of the White House, the Executive Office of the White House with NASA folks, and all the other sort of ministries, the other offices within the United States government who would be involved with those missions would have the information, all the federal agencies that are concerned by this. And if the impact is on US territory, then FEMA, the federal organization that is in charge of threats and local emergencies, would be warned. If the impact was not on US soil, then the Department of State would actually warn the other countries if the other countries had not had the information before. And of course, it would offer potentially to help. And this, I just wanted to show you that last slide about NASA and ESA's planetary defense budget. So the 2020 is a little bit different because I included some money that goes into big missions that were approved to go and impact an asteroid and its moon. I mean, technically you go impact the moon and you observe the impact of the moon by another mission. And so it's the DART mission, which is why you have this huge spike in money. It's not that it goes into pure research, it's also because what's included into that high spike in budget is the money for that specific DART mission. But if you look at the history, you can see that before 2010, not a lot of budget was put into planetary defense. But once the domain was really created and it became this managerial structure, this policy structure, then little by little, with the creation of the Planetary Defense Coordination Office at NASA and at ESA, the budget started to rise and missions started to multiply. And finally, to know more, you have different ways to learn more about planetary defense. Every 2 years since 2004, you have the Planetary Defense Conference. And this is a picture from Tokyo, Japan in 2017. Since then, we had one in Washington, DC. And for the one in Washington, DC, we had a lot of news coverage, and they compared us a lot with the Armageddon and us training for Armageddon. If you haven't seen this movie in a while, it's a fun movie, go watch it. And the next Planetary Defense Conference will actually be happening in 2021, so next year, I think April, and it will be potentially, right now it's been scheduled to be hosted in Vienna, but considering this current situation, some of it might be online, or we don't know. For now, we don't know exactly what will be the structure, if it will be web, if it will be half web, half in person, if it will be all in person. That is still to be discussed, but you will know more about it soon as the organizing committee is working on that. However, what is useful for you as maybe a non-planetary defense expert who still wants to keep being up to date and play the role of an agent of planetary defense, on this website that you will be able to find on the slides, you actually have the scenarios that those scientists and lawyers and policymakers train with. And so for this one, it was originally supposed to hit Denver, and we were able to push it away, but not enough. So it actually impacted New York, and there was it's a whole drama story, but it's very interesting if you want to learn more about space risk management, natural threat management. It's a great thing to train with. And just if you want to stay at home and you just want to find good information, well, the Planetary Defense Coordination Office of NASA, this is their logo, but you also have the webpage on the ESA website, the European Space Agency, that will give you a lot of information. Within Harvard, I teach on space law and policy, and I use planetary defense quite a bit, but you also have the Minor Planet group out of the Harvard Center for Astrophysics. You have the International Institute of Space Law that wrote reports about it. You also have some universities like Leiden University, some alumni wrote some great papers on it that you can find. You have the International Astronautical Congress. I think this year is going to be online, but you always have planetary defense sessions or planetary asteroid near-Earth object sessions if you want to just link online and get more information. The International Space University is a good place to find also reports, as their team projects sometimes have been focusing on planetary defense. And finally, the Space Generation Advisory Council, this group for students and young professionals between 18 and 35, is very active, and they have their own subgroup on near-Earth objects and talk about planetary defense. So this is my talk, and I'm looking forward to your questions. Thank you very much.
Thank you so much, Alyssa. That was fascinating. We are now going to turn over to questions. So I see some people have already asked some, but if you have not asked your question yet, please check out the Q&A button down at the bottom, enter your question, and we're going to be taking a look at some of those. All right. Oh, I forgot to mention one thing. If you haven't asked your question yet, if you could write in your question where you are located at the moment, just for our curiosity, I think, that would be great. Just put it in the text of the question. All right, so we're gonna start off with a question from Kieran. I think I'm saying that correctly. Is there an obligation for Congress to notify the public if there is a potential impact? And then if so, within what time frame?
That's a very good question, Kieran, and I'm not surprised you would ask a good question. I would say that, so it depends obviously on the country. In the United States, as you saw, I can go back to my slide, but they do have in some way an obligation to warn, but it depends if there is a confirmed impact and if it's going to be visible. So if it's going to be visible, if it's not going to be visible and it's not going to have an impact, they don't have to warn anybody. If it's going to impact, NASA has to give the information up and then to the executive office of the White House, and then they have to warn the rest of government. We have trained with FEMA, we have trained with a NASA representative, and we have trained with White House representatives. One thing that has been very interesting in the way we played out the scenarios was to leave to the representative of countries who were most of them just scientists and policymakers and lawyers, we asked them if they wanted to warn the population or not. And it was in some ways up to them always, and they could decide not to. And we tried to give that option open, because in certain countries, we could imagine that it will be mandatory. In others, they might not have to share that information. But in one of the general thought always that were shared during the Planetary Defense conference scenarios was that in this day and age, with social media and also with citizen science and the fact that a lot of citizens can track those objects themselves, the information would come out. So in terms of the legality of forcing Congress to share the information, we could imagine that it would be something that the White House could stop if they really, really wanted the information to be stopped. But at the same time, it seems impossible to do in this day and age, considering the flux of information. So my personal guess would be that they would be informed by the public. They would inform the public.
All right. So I have another question. First of all, thank you for your wonderful presentation, Professor Hadashi. It's your student, Tuana Yaziki here.
Hello, Tuana.
As we discussed in our previous class, could you talk about the importance of calling the planetary defense mitigation method nuclear device instead of nuclear weapon, so that it does not go against the Outer Space Treaty's important principle stating how states shall not place nuclear weapons or other weapons of mass destruction in orbit on celestial bodies or station them in outer space in any other manner? So I hope you got the text of that. I think it would be good if you told everyone just a little bit about some of the things in that question.
So thank you, Tuana, for your question. The gist of it, for those who are not currently studying space law and policy, is that in international law and also in one of the main treaties that guides space law currently, they're telling you not to have nuclear devices in space, not to actually, you have in international law this idea that you should not have nuclear devices, period, and you should definitely not explode them. And the thing is, they use the term nuclear weapon. And the whole debate around this is, do you call it a weapon or do you call it a device? If you call it a weapon, the term weapons comes, and again, you are going to find legal scholars who are going to be not going to agree with me on it, but I'm going to try to simplify it just for today. One way to see it is that the way to define weapon is that you have an intent to harm. So if you use a nuclear weapon in space against an asteroid, that doesn't work. You don't have an intent to harm the asteroid. When we say intent to harm, it's intent to harm other humans. So the idea would be to call it a nuclear device, because the only way to push an asteroid potentially in certain situation would be to push it away with this nuclear device. It would not be used as a weapon. It would be used as a technology, as a device. However, one of the problems comes with the idea of trying to push away an asteroid, and for some reason, the nuclear device doesn't detonate. Or you're going to have certain countries who are going to think, you know what, just to be sure and not to be scared, we're going to put some nuclear devices in space in case of an asteroid coming towards us, and this way we can use them to push them away. But that become sitting nuclear devices in space that could be used then against the Earth and be dropped on Earth, or used to destroy technology that is currently in space. So the way you would use the technology will transform the definition between a device and a weapon. And right now, you have, again, I'll invite you to look at the report on the legal aspect of planetary defense. We have had some ideas on, how to address the question. Currently, when we talk about specific mitigation methods to push away asteroids, we always use the term device, because we're not talking about a tool that could be used against other humans. However, we can understand also how quickly the use of the term device could be transformed if you were to use the device, leave it in space, and use it then for other purposes that could be defined as weaponry.
Okay, great. Moving along. So Masha from London Do any man-made technologies orbiting around Earth, such as satellites, cloud our vision of approaching asteroids?
So I didn't hear the middle part of the question. I heard do man-made objects and then satellites, and I didn't hear the middle part.
Do man-made technologies orbiting around Earth, such as satellites, cloud our vision of approaching asteroids?
Oh, I see. I see. I would prefer not to answer this question because I am not an expert in asteroid detection. But from my personal knowledge, I understand that the way to detect asteroids is using it. Waves, as I understand it correctly. So you're using infrared and you're trying to detect them this way. And that, with that kind of technology, the fact that you have other objects so close to the Earth that are so small would not impact your observations. However, I would much rather prefer to ask an astrophysicist whose actual job is to look out to tell me if those kind of satellites could blur their visions. I know that the problem comes with light pollution, in the fact that more you have those objects, less you can look up and you can do your observations. And because asteroids are so usually dark, they're usually made of iron and they're pretty much gray on black, so you can't really see them. I would guess that having a lot of light pollution out there could make the job more difficult.
I'll say a little something about the satellites. It's kind of similar to asking any type of question, do satellites orbiting Earth impact astronomical observations of space? You know, whether it's an asteroid, you're looking at a star or a galaxy. And up until recently, the answer to that was basically no, because even though there are a lot of satellites orbiting Earth, again, still space is very big. And sure, if you're doing a night of observation, you might accidentally get a satellite in an image once, and it might not have a big effect on what you're doing. But there have been some recent developments that have put more satellites in orbit than ever before. Certain companies, you know, in the last couple of years have started putting many satellites into orbit in order to have basically nonstop Earth observation, and putting them really close to Earth so that they can observe at very high resolution, replacing them regularly. And then there is this plan from our friend Elon Musk. Oh no, he wasn't mentioned in this one. He was mentioned in the previous one. Elon Musk wants to put, he's already doing it now, putting thousands and thousands of satellites in orbit into a it's not even a constellation. That's what they used to call groups of satellites, is constellations. This is more like a net, like a net surrounding the entire Earth. And the point of it is to offer global access to internet via satellite, which is a noble cause. But this is definitely, astrophysicists are getting concerned about this, because basically the idea is that there'll be a satellite in like every part of the sky in every direction you look at. So yeah, this is just one astronomical observation area that could potentially be affected.
I want to amend also my response, and I should have known better. One of something that is very much often talked about during the Planetary Defense Conference, I see a lot of colleagues sharing their data on the detection that they're doing from telescopes that are in space. So that's something I should have mentioned. A lot of near-Earth object detection comes from technology that is already in space. So it's not bothered by technology that is in lower orbits than those objects. So when you look at, right now, we're tracking the amount of asteroids, of near-Earth objects, of potentially hazardous objects. All those latest data come from telescopes and missions like NEOWISE. So, and it's actually kind of interesting because a lot of those objects, of those technologies that we're using to detect those near-Earth objects, are repurposed telescopes. So it's telescope that we're doing one thing, and looking at a galaxy or looking at something, and then now they're being reused to look at near-Earth objects and asteroids in general.
A lot to unpack there.
Yeah, so not space. You would. I think the best way to approach it is that for Earth-based telescopes, there could be a problem, but a lot of near-Earth object detection comes from space-based telescopes.
All right, more questions. Okay. So Alex Carl asks, it seems both IWAN and NASA PDCO are giving out warnings. Is there coordination between them?
Hi, Alex. So if I understand the question correctly, if IWAN and SEMPAGE are giving warnings at the same time, what would happen? Is that the exact question?
It's just, is there coordination between them?
Yes, there is coordination between IWAN and SEMPAGE. So the way, and I apologize again for explaining the acronym for IWAN. So IWAN, as I said, it's this group of international scientists all around the world, and they're doing detection, right? And SEMPAGE is that group of scientists all around the world that is planning those missions. And most of the time, actually, SEMPAGE and IWAN scientists are one and the same. I mean, you have a group of 40 and a group of 40, let's say, and you're going to have 25 that are pretty much in both. And the reason why it's not because you have a limited amount of experts, it's just because that's also how coordination works. If the head of IWAN, the president of IWAN will be always present in the discussions about SEMPAGE and vice versa, and they meet twice a year, plus they meet in committees where both are invited and talk with each other. So it's very much mixed all together. And actually the heads of certain groups, for example, currently one of the heads of SEMPAGE is the Planetary Defense Officer of NASA. So this is pretty much how all of it is intertwined. You have those experts who are then also part of national organizations focused on planetary defense and also international organizations, and they all meet together at international space conferences, but also among themselves when they work on detection and planning, because you can't really do planning without first knowing about detection.
Okay, wow, a lot of questions here. All right, we have Aurora in Houston, Texas. I would like to go back to your cool diagram, if you don't mind doing that, of NASA responds to a potential NEO threat.
Yes, I'm going to go back to that one. Hello, Aurora. I'm already looking forward to the question based on the fact that you want to see the slides again.
After assessing so let me wait till it's up so I can understand this too.
Here we go. Here it is. And full screen.
All right. After assessing that the NEO has an impact probability greater than 1% and hence reporting on it.
Sorry, it's a little slow because here we go. Okay, I'm listening.
Okay, where is it? Okay, so after assessing that the NEO has an impact probability greater than 1% and hence reporting on it, what other data are going to be gathered to go to the next step? Impact, yes or no? And in which time frame can we really be sure it's not going to impact?
That's an absolutely great question. And it's actually one of the main ones that is being brought up during the Planetary Defense Conference and the scenarios. This framework and this time frame can change drastically. So sometimes you will know about an asteroid impact years in advance, and sometimes the object is coming from behind the sun, or you did not detect it because right now we're not looking at 100% of the sky, and you might learn about the impact very late. So this idea of, oh, is the potential impact larger than 1%? Maybe right away we'll detect something with a potentiality of impact of 30% and not just more than 1%. Or we'll be able to know 10 years ahead of time that there's a potentiality of impact of 1%, and 5 years later, with more data collection and more observation, this rose to 5% to 10. And then at some point, you'll have enough information to clearly know the orbit, and if the orbit of the object is going to cross the Earth's orbit and impact the Earth. So as we said earlier, you can have two orbits cross and we would be completely fine because the Earth would not be at that time in collision with the asteroid. But if we were to find this 100% chance of impact, this is when everything would change. And that time frame changed completely depending on the object and the information that we have about them. So I will give the very politically correct answer that usually the Planetary Defense Coordination Office of NASA give, which is the more we can observe the sky and the more funding comes to planetary defense and asteroid detection, the more we can know about these objects and know about them ahead of time. And this way, there would not be a jump from a potential impact of 1% to a potential impact of 30% or 100% in a matter of days. It's always a risk, especially when we can't see 100% of the sky, but it's a risk that can be lowered if we have more, or if we do more observation, and also if we just keep on growing the world of planetary defense. It's a great question.
All right, yeah, I have another one here. This is from John in Cambridge. Hold on, where'd it go? Okay, you've mentioned the framework for reacting to an impact on a nation or region, but isn't an impact more likely to occur in the ocean? How would responsibility for effects of that be handled? By FEMA, as it would affect the US indirectly by tsunamis, etc.?
Well, now you spoiled my planetary defense scenario for my entire class. How dare you? It's an excellent question, and it's absolutely true that it has a higher chance, just because the Earth is covered in 70% of water, that the object would impact an ocean rather than it would impact the land of a country. One of the exercises, when I showed you the pictures about the different planetary defense scenarios that were organized in Japan, I think in 2017, one of the scenarios was that the object was going to impact Japan itself. And then through different exercises, we had moved the object into the Pacific Ocean. And that brought a whole new set of questions, because now when it was a mission that was led by Japan with some coordination efforts internationally with their allies, it changed completely the conversation now that this tsunami that was going to be created within the Pacific would impact mostly a lot of the west coast of the United States. So absolutely, depending on where it is going to impact, FEMA would keep track of the object. And on this chart, when it says if impact in US territory, FEMA would notify the federal, state, and local emergency responses. That's also what could happen if originally it was not supposed to impact the United States, but it was supposed to impact an ocean that is near the United States, or it was going to impact a country far away from the United States, but due to a mitigation mission potentially go wrong, then the object would have an impact. So this idea of including FEMA only if it falls on the United States alone is something that can absolutely be adapted and change depending on the type of information that we collect throughout this space mission mitigation plan.
Okay, I'm gonna do maybe like 2 more questions. So next up we have Akshay. And I don't know if you're gonna be able to answer this. I don't know if I would either, but will kinetic impact have necessary force to transfer NEO momentum? How exactly will it work? I think those are 2.
Will kinetic impactors have enough force to move away an asteroid? That's the question.
I think basically, yeah, to transfer NEO momentum, yeah.
Well, that depends on the size of the asteroid, right? So depending on its size, on its how do I call this word? Porosity, or if it's dense, if it has an iron core. It depends on the structure of the asteroid. It depends on the size of the asteroid. It depends if we can send kinetic impactors. One of the big things that always come up when we do the planetary defense scenario is that we always need to count on failed technology, because you can send impactors and think, with 4 impactors, we have taken care of this and we have pushed with enough force that this object is going to be pushed away for good. But sometimes some technology fail, and it can fail on the launch pad, or it can fail on the way, or it can fail and something could happen and go wrong at the moment of the impact with the object. So Yes, depending on certain objects, the experts from I1 and SEMpage will be able to say if using a kinetic impactor would be enough, and we would not need to go to look at other mitigation options or go towards the nuclear device option. But sometimes those kind of technologies, like any technologies, could fail, which would mean that not enough energy would be created to push away the asteroid in its entirety. And I just want to say that you have those potentialities also of breaking the object in pieces, and so many things can go wrong, which is also why the DART mission is such an important and interesting mission that is going to happen. I think it's launching in 2023, if I'm not incorrect. I'm not sure. But though in the coming years, you're going to have this mission where US probe is going to go and impact a moon. So asteroids can actually have moons, and it's going to impact a moon, and a European mission is going to come also. It's kind of a paired mission, and they're going to take pictures and make observations of that impact of the moon. So the more we do those kinds of observations, and the more we learn about the technology and how objects can impact asteroids and comets, the more we can predict what kind of technology would be needed when we were to be impacted on Earth by a near-Earth object. But again, I want to highlight the fact that I am not a planetary scientist, and that I can absolutely tell you more about the managerial structure, the policy, the legal side of things, but I would refer to you to the Planetary Defense Coordination Office of NASA, of ESA, the Minor Planet Initiative, Mary at the Mcauliffe Center. You have a lot of wonderful scientists, or Alex currently on this chat, who would be able to tell you much more about the science and technology side of planetary defense.
Yeah, I mean, so we have some good, still have many questions left. I think we're going to end with a good policy related one, but I'll take just one little stab at this last one. Will the kinetic impact have the necessary force? I mean, this actually comes to something that we talk about a lot. We work with youth a lot, and we've been talking to them, or thinking recently about how to talk to kids about, we really need to talk to them more about math and how important it is, because will it have the necessary force? Of course it will have, it will be given exactly the right amount of force to complete the action that they are trying to do. But as Alyssa pointed out, that exact amount that they calculate is only based on the knowledge that we have. So if your knowledge of the object, of the asteroid, is not complete, then you're not going to be able to do the math accurately. So they're both super important. These calculations you would need to do are really just the basic laws of physics, Newton's laws of motion, gravitation, F equals ma, basically. But if you don't actually know the mass of the object that you're trying to impact, then you might not be able to achieve the change in momentum that you need to. So that speaks to the importance of the exploration of the research that needs to be done. So yes, of course, they will absolutely believe that they have the right amount of force, but hopefully they have the right information to make that distinction. Okay, so last question that we're going to have tonight. And we do, the questions do get saved. We'll make sure that Dr. Hadashi gets all of them. I know there's some students in here, although maybe you can just ask on Monday or whatever tomorrow is. So here's the one we're going to end with today. What are your recommendations as a scholar to balance the need to develop mitigation systems, nuclear, laser, and otherwise, and the need for nation states to adhere to the spirit of peaceful uses of outer space? Do you foresee governments getting over their fears of geopolitical competition to collaborate on such a project?
Oof, I love this question. Who asked this question? I want to know.
This is from Jaren.
Okay, well, Jaren, thank you for your question. I absolutely love it. So many things that are coming to my mind right now to answer it. Let me organize my thoughts. I would say that one of the one of the things that I prefer, and that's the reason why I love looking at planetary defense management, and I loved diving into also planetary protection management, which are different things, as I told you at the beginning of class. See, I say class when it's actually a lecture, fine. One of the things that I love is that this system is a technocracy. Meaning that the word technocracy means that it's a system that is led and has been built by scientists. And it's not something that is often the case when you look at other managerial structures and decision-making structures. And if you look at the history of planetary defense, you see that you had this Schumacher-Levine impact on Jupiter. You had astrophysicists and scientists who started to do those observations. And then they started to collaborate at the UN level. And then they created this action team. And then you had Sempage and IWAN, who are also, even though they're under the head of the United Nations and the fact that it's an international organization, and they created those ad hoc, in some ways, those mandated groups that are Sempage and IWAN, those groups are also science-based. And those scientists then agreed among themselves about their structures, about the way they would collaborate with each other, about the way they would train with each other. And they created those planetary defense conferences. And in 2015, they realized that, oh, in addition to train and share our results, we are going to actually train and build scenarios to answer those questions. So all of the entire structure of planetary defense was built by scientists, for scientists in some way, but not only for scientists, for everybody. One of the first things that they've done, if you look at the date of the creation of IWAN and Sempage, it's 2014. In 2015, a group of scientists, part of Sempage, had brought up the idea of creating an ad hoc legal working group to bring in lawyers and to bring in policymakers. We're 6 years in the creation of their group, and a year after their creation, they brought in lawyers. A year after that, at their next planetary defense conference, you already had a panel bringing policymakers and lawyers. Now you have the planning for next year to bring in economists and to bring in historians and to bring in anthropologists. And so you have this way, I wouldn't see that you would see the national level and the international level. For planetary defense specifically, you see where internationally, people with the same goal, which is to protect the Earth from an asteroid impact or comet impact, would work together and little by little would aggregate the best way to work. They would create an informed decision. They will organize offices within the two main space agencies of the world. They would coordinate with countries all over the world who are doing missions that are observing and analyzing asteroid and asteroid samples. And in addition to that, they would bring in lawyers and they would bring in people from the national level and from the international level. So at the last Planetary Defense Conference, you had people from FEMA, and which is very much NASA and US related. But you also had representative of the UN, you had representative of Japan. It's the way it's being decided is less about politics because it is a system built by a scientist. And of course, you will always find people to tell you that, you know, technocracies have their faults and scientists are not neutral, perfect human beings. And they are some games of powers sometimes in certain situations. But what I could observe for the past maybe 6 years is this development and this incorporation of technologies and this incorporation of knowledges from all the variety of space academia and space knowledge in general. So, do I believe that planetary defense will work in collaboration with everyone? My answer is yes, because it's everything that I have been observing. Do I believe that maybe at the end of it, information might be blocked at the White House, information might be blocked at the Congress? It can still happen because any policy system is flooded and blockage will happen. But in the core of its structure as a technocracy and in the intentions that are being promoted at every IWAN meeting and Sempage meeting and UN-USA meetings talking about planetary defense, you can see this desire for collaboration. And it's not a desire which is what I call a kumbaya desire. Let's all hold hands and love each other because it's nice. It's also because one nation cannot look at all of the sky. So those scientists know that by working together, they increase their chance to protect everybody. Especially if it's an object that is more than 1 kilometer wide, we will all be impacted. And so those pity, my country is more ready than yours, don't make sense in the world of planetary defense. So it's a domain that gives me a tremendous amount of hope, because to me, it is one of the best examples of international collaboration in space, not only between scientists, but between all space knowledge.
All right, well, I think that is a great way to wrap it up. That was beautiful. So thank you so much, Dr. Adachi, for joining us. This was a very, very exciting asteroid day. It was great to hear this side of it. You know, we talk a lot about the science side, so it's great to hear this side. Would you like to leave everyone with one final comment about where they might look for more information if they're curious?
Yes, first of all, and thank you again for inviting me, Mary. Thank you for all the answers to the technical questions that you were much better fitted to address. So thank you for your support and your fantastic introduction. And thank you, Irene, for inviting me and creating this forum. I think usually when you hear asteroid, you think about comets and objects that can hit you. You can think about meteorites that you can buy sometimes. You can think about space and all the things that happen out there. What I love about planetary defense and having had this opportunity to talk with you today is that it really, especially this topic, brings together everybody. And not only by the way the planetary defense management is structured currently, but just in the essence of what asteroid detection and what planetary defense is about. So one of my advice would be, in my last slide, you saw different places where you can find information, but I just want to leave you with that piece, which is that it's not just a science and engineering topic. It's a topic that brings in, lawyers, that brings in psychologists, that brings in anthropologists and artists and policymakers. So if you're from any path of life, you will find a way, if you're interested in planetary defense, if you're interested in near-Earth object research or asteroids and comets, you will be able to find a way to participate and get involved. So I think today, Asteroid Day, you had the Asteroid Day channel, you had the fantastic event that Irene and Mary organized, and I hope this day leaves you with even more roads to explore.
Okay, great. Yeah, thank you so much. And I think I'll make sure to put some of the resources you recommended on our Asteroid Day page, so you can go back and find that if anyone needs to find any of that later. Thank you all so much for joining us. Just like I said earlier today, happy Asteroid Day. I hope everyone feels that it is kind of a happy day in a lot of ways after hearing this presentation. And we hope that you'll actually check out our website as well and maybe join us for some future live events. So have a great evening, everybody. And thank you so much for joining us.
Thank you. Have a wonderful